Hello Internet, I'm Guy. Today's video is the beginning of an adventure that I'm hoping you want to share with me. In my previous series of videos, I took an off-the-shelf Stirling engine kit that was fully assembled. It was made out of aluminum mostly, with bits of chrome and other silver-looking kind of metal parts that were cast from something, I don't know what it was. And what I chose to do was to convert it to a steampunk style Stirling engine by replacing a lot of the parts with brass and adding little steampunk gears and making a wooden base and giving it a lot of charm. That was me dipping my toes in the water of making a functional item using machining, and I freely admit I'm an amateur machinist. I'm just beginning to really work my chops as far as precision machining is concerned. So my next logical step was to challenge myself a bit. So I purchased this PM Research Stirling engine kit. It comes with a full set of parts here, and I've got more of them over here, and a beautiful set of blueprints that are very detailed. So in the kit you get some stock materials. This is some cylinders of brass and aluminum. You get a bunch of nuts and bolts, some fixtures, some O-rings, some bearings. This is a photo of the kit, and I'll actually put that bigger in the picture here. And then of course these are the main parts. So there's a big cast base here, there's a lovely brass flywheel, and these are the hot and the cold cylinders and other parts, including the glass part, where the cylinder which will run inside of here with the hot cylinder. So I'm going to follow the instructions, but I'm going to make it my own. So my plan is to be creative wherever I feel it's safe to be creative without compromising the performance and functionality of this device. So one of the things I'm going to do is use a little motor, as I did in the last one, that came with a motor / generator. And so I'm going to belt over to this from the drive of this Stirling engine, drive this motor, use it as a generator to light some LEDs to self-light the whole finished project. Along the way, I'm going to be looking for opportunities to do other sort of little creative touches, little flares. But more to the point, really, is I'm going to make sure that I do precision machining to make this thing work well. And the instructions are great. I feel very comfortable that I can do this. So join me on the journey. I'm going to jump in at some point here. I'm going to sit down before I start the next section of the video and just read every word of this very detailed set of instructions, and then I'm going to select some parts and start on the parts, and in each episode, for several episodes going forwards, I'm going to make a certain number of parts from the instructions and then possibly interpret some of them differently. So stay tuned. I'm going to start with one of the simplest parts, which is a displacer plug. It's just a simple piece of aluminum, and here's the stock that they provided. I've got it in a collet chuck because the run out on my collet chucks are better than my 3-drawer chuck. It's about 3 thou run out versus the 3-drawer chuck, which is around 8 thou. So it gives me a little more precision here. I'm doing all the standard things, facing it off, center drilling, and then doing the boring here. This is to the drill size that they recommend, which happened to be a number drill. So now I'm transitioning to turning down the outside diameter to the prescribed dimension. Right now I'm using my hand on the hand wheel of the carriage, but then I'm going to switch to using the motor drive that I designed for my carriage. I'll put a link below to that. That's worked out really well. I'm very pleased that I motor drived my carriage here. So you can see it's very precise movement. And the nice feature is that I can set it to stop on a stop switch, and I can reverse it to do a spring pass coming back, of course, which makes things just go so much quicker for turning down radiuses. So I'm checking the radius now, so I know I have a reference because it's now in round, and then I know exactly how far in to go. So I'm taking light passes. I'm not going to rush anything here, and I'm speeding it up quite a bit, of course, to save you time. I don't want to bore you to tears with lots of turning, but here we go. So then I'm going to stop and assess again, make sure I've got my dimension close to where I need to be. Checking the fit of the cylinder, and oh yeah, I think I overshot a little bit. It's a little bit loose. But you know, I think I can make that work, because in the instructions they actually say you could use some Loctite on there to hold it on, and I'll give that a shot. It's snug but loose, as you can see. So I indexed the parting tool blade to the outside edge and then used my DRO to find the dimension that I needed to cut this off. So I got that length. It doesn't seem to be particularly high spec for the length of this particular part, but I'm going to follow the instructions as accurately as I can. So this is actually within a thousandths or two of the dimension. Using a drill bit here to catch the cut-off part. There it is. So I'm just going to deburr that by hand. I didn't want to chuck it back up into the machine. It's easy enough to use a deburring tool. That's good enough. Now this is the displacer rod, which is made of 3/16 inch diameter stainless steel, and again I'm using my collet chuck with the low runout of about 3 thou. On a small diameter part like this, the better the runout, the smaller the runout, the better. So I'm just cleaning up the end, of course. Now I'm just going to file over the end. It calls out for a radius at the end. I think that's really more aesthetic than anything else, but what the heck, I will go with that. Doesn't take long. And then a little 440 sandpaper, clean it up a little bit. And then switching to Scotch-Brite, just to brighten it up a little bit. There we go, looks nice. So now over to the milling machine. I've got my slitting saw set up, which is a .025 slitting saw. It's the only one that I have that would be smaller than the cut that I need to make. So I'm setting DRO at the top, and then I'm coming down. Going to set my DRO at the bottom by just moving it up against the pin there and just watching for a slight deflection, and then that's my 0 right there. So I'm going to set my half function on the DRO, raise it up, get that right in the 50% mark, and then what I will do later is make 2 different separate passes above and below to get the full dimension that I need. I'm using lots of cutting fluid. And I'm pleased with this mandrel that I made for the cutting tool. I made that. It was one of the first things I made on my mini lathe, and it's working out really well. I've got several different cutter heads for it now that I've acquired, and it's working out really well. So now I've done a first pass at half depth. Now I'm doing a full depth cut here. Very careful and very slow cuts here with the stainless steel, of course. It takes a little more work and time. Now I've raised it up I think about 7 thousandths, something like that, and now I'm going extra slow because I don't want the blade to deflect out of the cut. So I'm just creeping right through that to make sure that it stays straight and true as it enhances and widens that cut. And as you can see, it looks pretty good. I did the same thing on the bottom, not showing that. So now I'm centering up I have the whole thing in a collet on the vise, of course, square collet block, and finding the center, of course. Finding the other side, and then of course I'll use my DRO to get exactly 50%. Using my center drill. I'm going to start in very gently to make sure it doesn't wander at all. And that's penetrating through into the slot, I believe. So now I can switch to the specified number drill. I'm going to go straight through with that. There's going to be a roll pin going in there, so I've got a little wiggle room on that number drill if it were to go slightly oversize. There we go. So I'm going to take that out now. And it looks pretty. I'm going to clean it up a little bit, just do a little filing and cleaning. So now I need to cut it to the prescribed length. So I'm setting the cutter to the center line of the hole, which is the dimension that the call-out calls for. and then coming over to the length that I need to do to cut this off. Of course, using my DRO to find that, we're using my carriage DRO. And there we go. Nice clean cut. So this is the full assembly. These are all the parts that I've made. The can is on the left in that drawing. So I'm going to put this in my drill press and use it as an arbor press. I'm going to tighten that down extra tightly there. Put the little displacer cylinder there underneath on a wood block. And I'm pushing really hard. And then it jumps a little bit. Oopsie, it pounded into the wood a little bit, but that's okay. I don't think that's a big problem. But what I'm going to do, you can see it sticking out a little bit there. I'm just going to hammer it back in again, set it in my vise and hammer it back. And now, of course, the Loctite. I'm hoping this is going to work out fine. I'm going to put plenty of it all the way around here. That stuff tends to run all over the place. So going into the displacer cylinder here, and I'm going to push it in and then go just a little bit further, because you can see little bubbles of Loctite coming out. Now it's just perfectly on there, and the extra glue is glooping out onto the wood. So that's good. Let that drain out. And hopefully this will be okay. I'm going to let it set and come back to it later. So this is the stock off-the-shelf piston rod displacer, and I didn't like it. So I've got some hobby brass that happens to be the exact same dimension, and the callouts here are actually number drill sizes, even though they've called them out in decimal inches. So what I'm doing is I'm measuring the outer edge to the outer edge here, and then subtracting 50% of each hole to get my total dimension. So that's my center to center dimension. Now I'm going to use my center finder to find the center of the vise jaws here, which of course I have the brass clamped in the jaws. Unfortunately, I didn't realize that I hadn't fully calibrated the vise to be true to the table. So it turns out that while this hole is perfectly centered, at the other end I'm a bit off. I didn't realize that till I'd finished this part, but it's really not a big deal. Again, it's kind of an aesthetic concern. What I decided to do, though, is drill all these decorative holes in this thing. So I'm doing center drilling and then boring it out. And there we are. That's going to look a lot more pretty. I'm going to round over the edges next, sand them over. And so now these are all drilled out to the prescribed dimensions. I just think it looks a lot nicer. So this is the first step in making this whole project my own. So here's the completed displacement cylinder and the piston rod. Thanks for watching so far. Please give me a like or subscribe if you want to see the rest of this series.